we're creating Digital Agribusiness. Our strategy for achieving the project's goals and objectives is based on a comprehensive vision of the agriculture of the future, usage of big data, advanced algorithms, and a reliable stack of the best open source and commercial software. We work with professional IT and scientist partners from different countries to support our R&D, software development, and integration. Currently, there are two industries in the Ukraine with an enormous potential for development and growth: agriculture and IT. We believe that Ukraine has a very talented IT community, and we invest in the Ukrainian IT industry. Before the project start, we tried to find a solution that would fit all our requirements and business size, but it turned out that it has not been created yet. Now we are happy to present to you Digital Agribusiness. It should ensure steady growth and efficiency of the farming division at Kernel and be a reliable part of the entire digitalization strategy of Kernel, which transforms our whole production chain. The planning module helps to quickly create a technology set according to the approved concept and in a quality manner. It models profitability scenarios, optimizes resources, and predicts expenses. According to the agreed algorithms, it calculates the amounts of seeds, fertilizers, crop protection agents, and other needed resources, as well as creates and visualizes the spring and autumn fieldworks. The execution module manages production operations on thousands of fields. It features automated risk detection, spring and autumn fieldwork schedule plan update recommendations, optimization of resources, online management, and visualization for the fieldwork and their progress. The monitoring module displays the indicator dynamics of each field, machinery, crop growth and condition. Also, it automatically detects risks and inconsistencies. It features a rich toolkit for timely risk mitigation. Transition from the existing software to a new mobile app will allow the agronomists to view the key field indicators, maps, and plan actual timely receive information from agricultural managers, request inventory amortization in the field, and more. A mobile app for engineers will allow them to view the machine's list, operating procedures, and other useful information, as well as request machine details. A mobile app for security staff will allow them to view the details on machines eligible for transportation and their drivers. Alex middleware platform is a central part of DAB that integrates all components into a single ecosystem. It ensures interaction of DAB, both with the kernel back office, external IT applications provided by John Deere, Case IH, Horsch, Trimble, and others, as well as field sensors and so on. The platform provides traffic and communication between all services and applications on one side and our planning, execution, monitoring modules, and mobile apps on the other side. Digital Agribusiness requires integration with internal business applications to create a single agribusiness management system. Usually, large agriculture companies need integration with three main business applications: enterprise resourcing planning, enterprise performance management, e-procurement. Digital Agribusiness will provide integration via API with all the versions of ERP, EPM, and e-procurement systems from 1C, Microsoft, IBM, Oracle, SAP, etc. Let's look at our planning module in more detail. The business process of planning implemented by means of the BPMN language is the core of our system. The key feature of this implementation is an algorithm according to which the business operates, as well as defined roles of employees and decision makers. Experience shows that such approach ensures the necessary flexibility, efficiency, and controllability of this business area operations. The technological stack used for implementation is based on the open source products. Among those are WSO2 Business Process Server and Activity Framework that provide one of the most efficient open source approaches to implementation of the BPMN-based business processes. Our process helps to combine financial planning, agri-technology, algorithms for optimal crop, variety and hybrid distribution, fertilizer norms and schemes calculation, crop protection agents, tillage, flow process charts, and machine distribution to ensure the most efficient use of each of 7,500 fields. With the help of the algorithm-based calculations, the process automation significantly increases the quality and speed of planning. Definition of the crop distribution scheme is based on the Kernel Agribusiness's strategic approach to production that provides an idea of quality and quantity characteristics of future yield and includes the algorithm to calculate a need and seed of own production. Financial modeling allows determining the financial metrics, EBITDA and profitability. for the approved or modeled crop and yield structure for the set of crops selected in the previous module. Planning of crop rotation for 1 year uses the algorithm of the most suitable scientifically proven crop distribution adjusted to production conditions. On each step of the process, the users can view the necessary field information, location, weather history and forecast, soil properties, crop and yield history, technology used on the field, and so on. Conventional yield determination is based on defining potential yield and actually possible yield taking into account water and climate characteristics of the growing area, soil quality properties, and crop biological characteristics. Development of the hybrids and varieties distribution map uses the algorithm that recommends hybrid and variety placement. Development of the nutrition system including mineral and nitrogen fertilizers, microfertilizers, and other biologies uses a set of algorithms based on the agrochemical field indicators, field crop history, expected planned yield, crop needed nutrients, and more. The plant protection system development uses an algorithm of the most fitting protection system determination taking into account all the climatic peculiarities of the area and phytosanitary conditions of fields. The tillage system development uses the algorithms of enlisting the technological operations aimed at maintaining high-quality soil properties. The module of designing, correction and approval of the process map for a year creates the flow process charts for fields, geozones, clusters, and the whole kernel agribusiness. The flow process chart includes all direct expense areas for spring and autumn fieldwork calculated on the previous steps of the business process. Also, it contains additional expense areas such as elevator services on grain refinement. Additional algorithms calculate machine load, determine the need in rented machines, and list the machines that are of no practical use and can be recommended for sale. All agreed direct expense areas will further be used for agribusiness budgeting. On each step, the system allows generating reports that can be viewed on the interface or exported in the XLSX format. In the planning module, there are nearly 30 various reports for agronomic service, cluster managers, accountants, engineering service, and kernel agribusiness top management. Also, there is an export to the BI system for custom report generation. The planning model currently implemented by Kernel has its own peculiarities due to a huge land bank with 7,500 fields, so you will probably hear some new terms. This demo shows several parts of the planning business process without displaying all its features. Having logged into the system, the user sees the list of crop ratio schemes. The user selects crops and adds the qualities of one of them. Then the user defines seeding and deviation percentage for each crop and its quality. And when all data is entered, adds geozones to the scheme. Then the user repeats all the actions with the remaining schemes. In the finance modeling module, based on the actual cost and capacity of the crops for the previous year, the expenses for the yield year are modeled. The system automatically calculates the EBITDA and profitability metrics for the crop structure approved in the previous module. Also, it will recalculate the financial metrics for the modeled crop structure in case of planned crop yield growth and much more. The next step is crop distribution. When the user opens a geozone, they see the scheme to which the geozone is added. The scheme displays the current and planned state. Below is the list of fields and the most appropriate crops defined by the system algorithms. The user can leave a note, create land areas, change field purpose, and alter crops. If the user alters a crop, there are many different criteria of such alteration. All these actions can be accessed from a map view of the field. When the crops are approved, it's time to select varieties and hybrids. Having opened a geozone, the users see combinations of the variety hybrid distribution suggested by the system with use of algorithms. The user can change the combinations if needed. After the variety hybrid distribution is approved, the user moves on to the nutrition system development. Development of the nutrition system includes scientifically proven methods of mineral and organic fertilizers application that ensure planned crop capacity and increase soil fertility. According to the algorithms, the system calculates rates of the NPK primary plant nutrient and defines fertilizing measures taking into account the actual level of soil provision with the plant nutrient. Also, it schedules implementation of measures, defines the ways of fertilizer application according to the available production capacity, and selects the most appropriate fertilizer for each field. The system enables the user to modify the nutrition system within the allowed scenarios. On this step, the system automatically assigns plant protection system to the fields according to their phytosanitary condition. The user can adjust the tillage options, experiment on the designated fields, view the information on crop-destroying insects and pests specific for each field, and send the completed operations for further processing. The system creates the most appropriate set of tillage operations for each field based on the previous crops, selected crops and soil compaction taken into account its depth. The user can add and delete operations as well as change the number of passes on the field and area of the operation, marking all the changes with corresponding comments.